Hello guys, welcome back to Abstract Digital Technologies YouTube channel. In today's tutorial, we are going to be looking at CTE in SQL. My name is Ezekiah Omoyemi. What is CTE? CTE stands for a common table expression. It's a temporary named result set that you can reference within a select, insert, update, or delete statement, including merge. It helps simplify complex queries. It improves readability and maintainability of your SQL code. And here is the syntax. You start with the clause statement. With is the keyword used to start the CTE definition. The CTE followed by the CTE name. This is the name assigned to the CTE. You can reference this name in the main query itself. Having that, you now, the third is the column. Which of the column you are referencing. So this is optional though. Specifies the column names for the CTE. If not specified, the column names are derived from the query results itself. You follow by the hash. The hash indicates the start of the CTE query definition, followed by the select column. Now, in the select column here, the query that defines the result set of the CTE, it can include any valid select statement, including joins, aggregations, and subqueries. Followed by the from clause, the from table name. This specifies the table or tables from which the data is selected. Where condition, optional specify, this is optional as well, specifies any filtering conditions for the data selected. You now have your main query. This is the main query for the CTE. So select from CTE name, right? So the select from CTE name, this is the main query that references the CTE. You can treat the CTE as if it were a table or view within the main query, right? So let's see how we can use this CTE. Let's see how we can use this CTE in SQL. The first thing I need to do is to activate my database. I'm going to be using the HR database within my system. I'll say use HR, and let me execute this. Now, this is the database I'm going to be using. Within this, my HR database, I have several tables, right? And the table I'm going to be using is in this tutorial is the employees table. Let me introduce you to the table. I'll say select all from employees, right? And let me execute. This is the table I'm going to be using. Now, in this table, here are the columns, right? We have the employee ID down to the department D. If you look at this table closely, you can see we have the salary column here, and we have the manager ID, we have department ID, and this table contains the vital information. In our first use case, let's say we want to use a CTE to calculate the average salary for each department. So that is going to be our first use case. So our first use case is going to be first use case. Calculate what? Average salary for each department using CTE. So how do we solve this? Like we said in the syntax introduction, that whenever you to start your CTE query, you start with the width, then the name of the CTE, the temporary name you want to give to your query. For this case, we say department AVG salary. That's the name. Then as words, this is where we select words. We're interested in the department ID. The department ID, right? And our average function will be on the salary. As let's give it a name, average salary. From where? From employees table, right? That's the table we are using. Then we are going to group by the department's ID. Let us close our CTE expression here. Now, this is our CTE, right? Next thing is our main query, or Ctrl Z. Our main query will now be select. What now are we selecting? E dot employee underscore ID, E dot first name. I'm concatenating this with the last name plus E dot last name as employees underscore name, right? Followed by the employee salary. Then I will say what? DSA dot our average salary as what? Departments underscore AVG underscore salary. From where, please? From our same employees table, E, right? We are going to join it with our CTE. So I'm using the inner join. Then what is unique to all of this? The name. We supply the name here. Inner join. Inner join. Okay. Inner join department average salary, because that is our city name, the city table. That will be what? On E dot department ID equals to DSA dot what? Department ID. What are we ordered by the what now? Employee name. Let me execute and let's see what we have. Let me execute this. Here we go. Can you see that the words we fetch the department average salary? So the breakdown of this query is this. I defined my CTE, which is named what? Department average salary. And it calculates the what? The average salary for each what? Department using the department ID. Then in the main query here, I use the CTE to join the what? The employees table. This allows me to retrieve each employee's information along with the average salary for their department. And finally, I selected the employee's ID, then concatenated the words, the first name and the last name, the salary, and the average words, the average salary for the employee's department from the CTE. And then the words, the result set is ordered by the words, the concatenated employee's name. So this is how this query words goes. Now, going further in our second use case here, but before let's bring back that particular table. I'll say select all from employees, right? And execute. Look at it. We have this manager ID and we have the employee ID. So this is a kind of a well-structured data, organization data, because we can tell that we have some the employees, they have a manager that they are reporting to. Now, let's say we want to find out employees who is reporting to another employee. What do I mean by that is we are going to find the employees using the employee ID to locate the manager. Each of these employees are what employee is reporting to. And what we are going to do here is to use the what recursive CTE, right? We are using recursive CTE to get this work done. And what is a recursive CTE? Now, a recursive CTE is a common table expression in SQL that references itself within its own query. It is used to perform recursive queries, which are queries that involve a repeating process multiple times until a certain condition is fulfilled, right? So, and your recursive CTEs are commonly used to traverse hierarchical data structures like organization charts, like we do here. This is a typical example of a structured data because we can see there is a level of hierarchy here, right? So to solve this particular solution. What I'm going to say here is let's say second, let me make a comment. Second use case. Find employees who is or who are reporting to other employees, right? That is the problem we want to solve. To start with, we said with what? Let us give it a name. Recursive what? Recursive employee hierarchy as what? Select, what am I selecting? I'm interested in the employee's ID. The employee underscore ID. We are retrieving the first underscore name. We're interested in the last name as well. The manager ID itself, the manager underscore ID, and what else again? Now I'm going to assign a depth to it. I'm going to assign a depth to it. I will say what? 0 as depth. From, in a short while, I'm going to explain this. From what? Now, from the employees table, right? That is the table we are using. We say where what? Where manager ID is none. What am I simply saying here is this. I have given it a name, which is recursive employee hierarchy. Now, what happened does is that the anchor member here, select employees who do not have managers, where manager ID is none, and assigns a depth of 0 to them. So any manager, any employee that doesn't have a manager, we are giving it a depth, like a number tag, which is 0 as a depth, right? That is what I have just done here. Now, that is not the end of this query. Going further, I'm going to use the union all here. Union all. Select what? Select, what am I selecting? E dot employee underscore ID. All the things we've selected earlier in our recursive table statement there, over there. The last name, yes, the last name, E dot last name, then E dot the manager underscore ID. What else again? Then redepth. Redot depth. I will explain this shortly. Plus what? 1 as what? As depth. from where now? Employee, this employees table E. Then I'm going to join this query here to the CTE above. Inner join what now? Our recursive employee hierarchy on what now? On E dot manager ID equals to dot employee ID, since these are related. So this is where they are communicating with each other, iterating. Now, let me explain this part. I'm using union all here, this union all, to combine the results of the anchor and recursive words members. The anchor and the recursive member here, all of this and all of this, right? The main select, that's what I have done. So I am saying that what the anchor member should select all employees who don't have managers, probably the top level managers, right? Then the recursive member then selects employees who report to the employee selected in the previous iteration, and continues this process until no more employees are found who report to the ones selected in the previous iteration, because we said it is a repetitive process. It's repeating itself till a desired result is achieved, right? So I'm now going back to my main query now. Here, I'm going back to the main query. I will say select the employees employee underscore ID, followed by the first underscore name, the last name, manager ID, then our depth now, the depth we are given from what now? This is coming from our recursive employee hierarchy above. Then I'm going to order by, what am I ordering by now? The depth itself, the last name, and the first name, right? Let me execute this query now. It's a little bit long, but I've broken it into chunks. You can see, right? So this way, I've used the CTE to build a hierarchy of employees showing who reports to whom at each level. So this provides a clear view of the employee hierarchy. We can see that the non-value here means that this particular employee doesn't have any manager. Perhaps is the founder, the CEO of the company. And you can see that all the employees who are reporting to manager with ID 100 are assigned a depth of what? Of 1. And then it is incremental by 1, which is what? You can see the manager's ID 101, 104, 114, they are giving 2 down to the last word, to the last depth of 3. So this is how we can use what recursive CTE. Lastly, let's see what we can do again. Now, what we want to do in this third use case is we want to rank employee. We want to rank employees based, we want to rank employees within each department based on their salary. So our third use case will be rank employees, rank what? Employees within each departments based on their salary, right? And then based on their salary, and then what? And then select the employee what? The employee details along with their salary rank. So let's see how we can achieve this. Now, to achieve this, we say what? With what is the temporary name we are giving to it? We say rank what? Employees as what now? Then we have our select. What are we selecting? The employee ID. We are selecting all their details, the first name, the last name, and seeing their department ID, the salary column, right? Now, I'm going to introduce a window function called the row number. I'm going to use the row number function to assign a rank to each employee within their department based on their salary. And then the ranking is going to be in descending order. So to do this, I will say row number, which is a window function, the row number over then I'm going to partition, because we are partitioning, we are using a window function, partition by department underscore ID. Okay, I will say order by the salary is going to be done in descending order. I'm closing that. Then let me give it a name as salary rank. That is the name of that column. From where, please? From employees what table. Then I will close this. So this is the CTE. Let me go to our main query now. I will say select all the things we've listed there, employee underscore ID, the first name, the last name, the department ID, the department underscore ID, department underscore ID, followed by the salary. Then lastly, we are going to introduce this word, the salary rank. That is the column in our CTE over there, the salary underscore rank. This is what that is what we want to see in our statement, in our result from same word, ranked from rank employees, right? Then I'm going to order this by department ID and salary rank. Let me execute the query. Now, let's see what we have. Hola, here is our result. Can you see? Look at it. So these are the department ID. This is the salary rank. So in this department, the highest salary is 4,400, and it goes thus, right? So this is how we can use CTEs in SQL. CTEs makes your query readable, reliable, and dependable. If I'm too fast for you, you can take it bit by bit. You can slow the video for you to get whatever I have captured. And I'm going to provide this query. I'm going to provide it in the description box. You can get it from my GitHub repo. Make sure you get it. And if you like this video, try as much as possible to comment, like, share, and subscribe to my YouTube channel. See you some other time. Thank you.